Hi, everybody, and welcome to the Automation Village, a show for people who love automation and like learning about it while you're actually on a break from doing automation. And that was our opening theme, which we like so much. We played it again. My name is Chris.
I'm Natasha, and I'm filling in for Dave.
And filling out our team this week is producer Pete and newscaster Keith.
Right, so this is the first time that we are back in the studio. Nice to see you since Summerfest.
That's right. So Summerfest was our live online users conference that we did last month, and it went really, really well. We had lots of people from the Trihedral team all pitching in, doing some heavy lifting. You were actually doing some actual heavy lifting.
I did do some heavy lifting down to the post office, and if you're wondering, why did you go to the post office for a virtual event? Right, so the lucky first 350 people who registered, they got an awesome Summerfest t-shirt and sunglasses. The next 150 after that got the awesome t-shirt. Everybody over 500 got some really stellar content.
Right, and if you've got a pair of sunglasses, put them on now for a special feature. It makes the Automation Village darker. So we've had people at that conference from over 40 different countries, and we got to show off some parts of the software that most people don't get to see.
Yeah, so our CTO, Devraj, joined us, and he went through some of the features that's been released so far in VTScada version 12. Spoiler alert, that's over 80 features.
And then we had our president and chief software architect, Glenn Wadden, and he gives a sneak peek at some of the stuff coming down the pipe for 12.1 or whatever we end up calling it.
Yeah, whatever we do end up calling it. And we ended the show in what was my opinion, the absolute best virtual black tie award ceremony on the internet.
My virtual tuxedo looked amazing. Also, we actually had a real live magician, which was awesome.
Yeah, so as you can tell, I'm hosting today. I'm counting on you, our audience, to keep our live chat going.
Right, so if you're on the live chat right now, if you've got a good automation joke, or if you want to wish your mother a happy birthday and she works in automation, do that. And if we like it, if producer Pete likes it, he'll actually make it scroll across the bottom of the screen where everyone can see it.
Awesome. Chris, tell us what's coming up this hour.
Right, we're going to combine some tips and also some tricks for a segment called Tips and Tricks, both in terms of general automation and SCADA software. And also, we're going to have Lee Kibler from Riviera Utilities, who you may know from the show in the past, and he's going to show us a revolutionary and award-winning new process that they're using to vastly increase the capacity of their wastewater treatment plants.
I am excited to hear about that.
Yeah.
I'm also excited for our industry roundtable to be joining us again. I know that this is a segment that a lot of people have said is their favorite segment.
Like me.
We're going to kick out a new segment, hard to say. But the thing I'm most excited for, of course, is contests.
Right. So we always have contests on the Automation Village. And this one that I'm going to tell you about right now is called the Code Phrase Challenge. And what that means is at some point during the show, we're going to say Code Phrase Challenge and put a phrase up on the screen. And you are going to take that phrase exactly as it's written, put it in the subject line of an email, and send it to, you can see it here on the screen, natasha.lutz@trihedral.com. and hit send, and you might win.
Yeah, so generally in this contest, the Code Phrase contest, we give away to the first 2 people that enter.
Right.
But in honor of me hosting today, I'm going to give away more of Producer Pete's money, and I'm going to make it the first 3. So the first 3 of you that come in at $100.
So 3 people could win a $100 gift card from an online shopping entity that used to be famous for books, but now just about everything.
Is there any rules with that, Chris?
Oh, in life, there are always rules, Natasha. For example, if you work for Trihedral or our parent company, Delta, hi Delta, you may not enter. If you're related to us, you may not enter. If you've appeared on the show, you may not enter. Otherwise, you may enter.
So with that, I'll leave you with Eric Brown from McKim & Creed.
Hello, my name's Eric Brown. I'm with McKim & Creed. I've been with McKim & Creed for about 20 years and been using VTScada for a little bit over 20 years, and I'm a senior INC technical specialist with McKim & Creed. Today I'm going to go over the built-in function called pickValid from VTScada. It's a good way to set default values. One of the things that Doug pointed to me, my good friend in support, he pointed out that the values don't show from PLCs until they're read. So this is a good way to set default values. But in my case, I had an issue with one of my widgets not showing until I clicked a parameter that I called orientation within that. So what I wanted to do is set that value to false so it always shows up. And I'll demonstrate what it was doing so you can see why I needed to change that with this pick valid function. So this is a widget that I built, and if you click on draw, it'll take me to the overview screen, and then I can pick my widget. So here's the pump widget. And as you can see, it doesn't appear until I go in here and I click on orientation. But I want it to be false. Most of the time it's going to be this way. So in order to fix that, you go into the pump widget, you edit, and it'll bring up the widget, and then you go into the source code. So here there's no pick valid, but to speed this up a little bit, I went ahead and did all the code, and then what I'll do is I'll go over this code. Up here. So here I added this function called pick valid, and here's the orientation status, and then you have to create a temp value so you can push that into there. So here I just called it set default, because the default that I want is to be false, so it will show up on the screen. And then if tag widget main, and then you do the orientation temp equals pick valid and make it a 0. What you can also do, one of the things, I have a faceplate tied to my pump. I don't want the trends to show up along with it, because otherwise it double stacks it. So you can also set your disabled trend to 1. So I'm going to save this, and I'll go back, and I'll go ahead and compile this. Sorry about that. I had to find the one that says standards. Click OK. Now my changes should be in. So we'll go back to the overview, and I'll drop that widget on the screen, and you'll see that my problem has been solved by using this function. See, and now it defaults to being false, and also the disabled trend is checked. So now if you go to here, go into runtime, my faceplate comes up, the trends don't show up, and this is my faceplate that I have created for this pump, and we're using the high performance graphics in this application. So as Doug pointed out, this is very useful, and I recommend doing this pick valid when you create custom widgets. That way it'll help you set some of these default values. And I could even set the default values. Well, in this case, we don't have any more other than the orientation. But I have some other widgets that I've created where I could set the default values, and this would help the programming. So all you gotta do is drop it on the screen and go. So again, here's the pick valid function. It's also, if you hit F1 while you're in here, you type in pick valid. It's very useful to use this F1 when you're programming in VTScada. It'll give you how to use it. Here's the pick valid function. Here's the parameter that they listed, and then here's the value they're setting as the default. And that wraps up my my introduction of the pick valid function.
Hey Pam, how are you?
Hello there, Chris. Hello, Natasha, wherever Natasha went. How are you?
Just over there. So it's where are you this week? Normally when we see you, what's so great is that you're in your car or you're out on a beach. Where are you now?
Today I am actually at my house, and it's raining out, so we're not doing this from outside, but our future is, so I just had to wear your VTScada shades.
Oh, very nice. They look great on you.
I'll just take them up there for now so I can actually see, but it is raining here in the Carolinas. That's for sure. You guys doing well?
Great. Oh, we are. Yep. It's
Awesome.
a beautiful sunny day here. I wish I had my sunglasses with me.
There you go. Well, thank y'all for the shirt and the sunglasses. I really appreciate it. And looking forward to another great roundtable with Ian, Lee, and Pete. That's for sure. So thank you guys very much, and welcome to the Data Wave. Our theme for today. Yeah, there we go. Look, now we got our names on there now. There's Lee, there's Pete, there's Ian. Our theme for today is how we drive adaptation of new technologies and innovations within our industry. Lots going on, so many things happening very fast, but how do we as, multiple industries, water, wastewater, power, transportation, really drive adaptation of that? Certainly a lot of things have changed these past couple of years due to COVID and the use of technologies and how much more efficiencies they can run. But it's just interesting now that we're moving a little back to in-person type events outside the virtual world. I just got back from Virginia Water Jam, which was very fun for the folks here that are on the call from Virginia. WebTech Chicago is coming up in a couple weeks. And then Ian Hughes said he was coming back from Smart Water over in Florida. So lots of conversations going on now, back to in-person and virtual. But I was reading, actually, we all do a lot of reading in our world, whether it's on LinkedIn or through whatever learnings we do, but trying to look at how do people react. So what's different in the buyer-seller world in like right now versus 5 years ago versus 10 years ago versus 15 years ago within our industry? I've been in the industry since 1987, but what really looks different? And things do look really different, let's say 5 years or so. And our job as either public-private and working in partnership with folks is really those collaborative type conversations, but looking at how does the individual, how are they reacting differently? Looking at their team, how are they reacting? Looking at the organization itself and where does it move and where does it go and at what rate? And then of course the industry as a whole. So we're going to try to look at today at a lot of different levels and try to have a discussion over how we can adopt. How do we adopt these new technologies moving forward and both the individual, the team, the organization, and the industry? So we're going to start with Lee from Riviera, who you're going to see Lee later as well. Just talking a little bit on the culture, Lee. So Lee, what are your thoughts on this topic?
Well, thanks, Pam, and it's always good to be with you guys. Hey, it's not raining here for once. For once.
Thank you. You sent it to me. Thanks, Lee.
It's not raining here either, by the way. And I'm in the Carolinas, that's why I'm joking.
The thing, whenever I was in college, and I got out of engineering school, the predominant thing, I'm going to show you a bit, is nobody gets fired for buying Big Blue or IBM. And so that was a pervasive during that process. Now I'm in the water and wastewater industry, which is more of it's more of a linear type process where we have established processes and we move through time and we try to drive uniformity. And the only times we have in our industry for making significant innovation would be when equipment's worn out, when we had a regulatory compliance issue where something changes in regulations, or there's a major population move where we have people either coming or going into our communities. So the incremental innovation we have would be the opportunity to do such as buy variable frequency drives, or to add new instruments like Pam you would provide, or software products like Ian, or when we do a major upgrade, a major time where we can do innovation is for population growth, where we have to build bigger and newer facilities going through time. Now, the whole measure of our culture tends to not allow for innovation because we're more vision in optimizing existing processes. So that can lead to what we would call an established paradigm or groupthink. groupthink tends to say, okay, we've done it this way for 100 years, like wastewater. Let's continue to do this. This is an established process. We know what's going to have the input and outputs. So there's a motivation to continue down that road. So what we have to do, in essence, is try to move to innovate by staying current in our industry and keeping our minds open. Now, openness of mind is a very difficult thing. We all say we want change. We all say we want to make things better, but man, we are really rooted in the past, and we have to get over that. So I've gone through it. You do not make a major change in a process without taking risk. In our organization, we need to try to keep people that are willing to take risks and that take risks based on data and can present that information. So that's kind of the way it works in our industry.
It does. How does that affect, before we move to Ian, how does that affect your 5-year, 10-year, 25-year, 50-year, where you're making those types of plans at a utility? And I'm going to ask that question to all three of you guys. But with Lee, how does that affect in your world?
Well, the tendency in a low bid society is to make decisions based on net capital cost rather than total system cost. I mean, the cost of a piece of equipment over time. So that's a change in mentality that we have. Is, hey, what's our total cycle cost of this investment, rather than just, hey, what is our net price for this bid? So that looking over time would be a key process indicator of change. Also, we can also make decisions based on current regulations and not look at the tide of the industry. The tide shifts, rises and falls. So we're not going to get a situation in our industry where regulations are going to get looser. So if we invest our money in processes that are antiquated, then we are not actually protecting our ratepayers. Clean water is a key process indicator for our society as a whole. So we need to make sure that we're delivering clean drinking water of the utmost standard beyond regulations, and also wastewater as well.
Oh, that's well said. Let's jump over to you and your thoughts on the topic.
So with water, you're dealing with a vocabulary word, I'm going to drop one, monopsony, which will be used at least twice
to say the right
in
word.
a trivia. So
like
monopsony is a situation where you have one buyer and lots of sellers. And it's an inversion of a monopoly, in that you may think that, these vendors have all the power because there are only a handful of them delivering to each one of these water utilities. Well, that may be true. The buyer has a phenomenal amount of power because they can be stubborn. And they can also just dictate what it is to the sellers that the price is going to be. And in water, whether you're going to a utility that has 50,000 consumers, 800,000, or 1,000, each one of these makes their decisions on their own. And because there is typically not that much competition amongst them, because they've been kept out of the political loop of trying to increase property tax values by boosting up the value of the land because the water is better, you don't have the competitive drive. All that said, we aren't exactly going around with horses and buggies anymore in water. So why is that? And the reason is that people like Lee exist, and people at many other water utilities too, who genuinely care. And one of the things that I was asked in preparation for this talk were, what are the things that we found in cultures similar to water that have proven to be great at dislodging? If you come into an institution in a position of leadership and you realize that the thing just isn't making innovative changes in spite of it being better for the organization, how do you do that? How do you fix that? Well, the number one suggestion is have everyone watch Admiral McCraven's speech at the UT commencement a couple of years back. That's on YouTube, and it just changes the way people behave at an operational level. Fine. The other thing is you just need to start instilling this mentality of we can be living a better life here. So another suggestion is you print out something that says never hold a sheet of paper twice, and you put it on the wall. It's about changing a culture. So you're setting a wall rather than a bar that people therefore have to jump over to make the quality of life for the end consumers. And it's just these simple things that can fix the problem. And I will also note that competition may bring the best out in a product, but it also brings the worst out in people most of the time. So if you can avoid that in a monopsony by just having a culture that says we will do better, then you're going yourself very far.
And to me, it's all about the collaboration. We're like, if you have one buyer and multiple sellers, it's truly about the technical that's going on in those conversations. What can be better for that organization? But that's true. And it made me think of our lab adage, Lee, Ohio, only handle it once. And you have that principle in your head that helps you in your digital technologies too. But it's called the Ohio principle. Mm-hmm. So fantastic. Cool. Thank you. And I will never be able to say the word monops can be, but I'm working on it. So Pete, how about your perspective?
Yeah, well, I mean, when you consider the adoption of technology and innovation and kind of that barrier that tends to creep in, and a lot of it just comes back to pure trust. And I often kind of say to myself, well, whether it's a vendor like ourselves or whether it's you Pam or you Ian, and you arrive in and you're trying to show something innovative to a utility or factory or whatever it is, and people just don't necessarily want to budge, and it really just goes back to that trust factor of unless you can present evidence obviously beforehand, no one's going to even try it, which in a risk averse kind of society, then that failure, and we said this before, but failure isn't kind of accepted, especially in the public utility world, even as part of a trial. They don't, it's not considered that way. So really, I guess to build trust, and it was actually Ian had reminded me of something that we discussed, which sometimes you need, it goes back to the importance of storytelling, and it really is like, the way you tell it. There was a comedian who used to say something like that. It's, the way you tell the joke, the way you tell it. Well, people relate a lot of the time to a story that is compelling. And if whatever it is that you're trying to do, if you're thinking about, okay, well, what's going to engage with this person that you're across from our people, and you're trying to present something, and you say, right, okay, well, I'll try and relate to them at something that they really know, to take the complexity out of what you're trying to do, because we're in a world of complexity, let's face it, right? So showing huge layers of complexity and trying to talk to someone, and you're kind of talking down at them sometimes, you mightn't realize it. Well, if you can change that to just take it back up to what problem are you going to try and solve in this thing, and relate it to a story or something that they're actually going to understand better. I think that that if more companies and more people kind of engage that way, I think that you'd build a culture of innovation, because people would trust that stuff is going to happen, but it's not the end of the world, and you show how it was done somewhere else with or whatever, So that's all. That's I guess what I have.
No, that's a really important point, because you want to make it relatable. Because all these technologies, if you take at it and look at it holistically, see if y'all agree with this, it's going to affect the maintenance person differently than it would affect the lab supervisor, that affects the chief operator, that affects the superintendent, that affects the engineer. All these innovations that are out there are very holistic. It's not just one widget. It's a true solution. But I think that you're putting these very diverse teams together, and even organizations, make it relatable to that person. So how does it affect their day-to-day life? I think that's very true. Lee, would you say that's a statement for the teams that you have there at Riviera?
Yes, I would. And I would like to reinforce that what is going to be your utility, your teams, your individual legacy. are you going to present a legacy going through time that shows that you cared enough to look to save energy, to save water quality, to improve people's lives in the organization and in the community? What will your legacy be moving forward?
Well, say, Ian, you see a lot of different people out there in your world, all different kinds of organizations. Would you say that was true of most you're seeing if you make it relatable to different parts of the organization, or what are you seeing?
So what I'm seeing in water is rather unique. Water has a very high percentage of people who came out of the military relative to the other sectors that I tend to find myself interacting with. So they tend to be very good at managing large teams of people who perhaps have relatively limited experience outside of one particular speciality. And I think what Lee said is completely accurate on the entire water industry. There's either a sense of operational dignity or there isn't. And the ones that do have that sense of, by God, we're going to do this right because that's who we are, they get themselves moved along quite well. They have a direction. If you think that there's perhaps a better direction that they could be taking, they may hear you out and take it. In sectors like cybersecurity for a long time I've heard was argued to be a thing about 90% art, 10% science. And that's kind of inverted itself. So by this juncture, you have a shifting of the culture and of what type of person wants to be in a sector that's 90% science rather than 90% art. And you're seeing that happen inside of the organizations that have large cybersecurity teams. What does that mean? I'm giving you the fuzzy answer because it varies entirely based upon where each organization is.
No, I agree. How about you, Pete? Because you see a lot of people out there as well, many different organizations. What's your perspective?
Yeah, and actually, I'll have to say I was slightly distracted. So could you repeat the question?
Oh, just looking at, that's okay. He's also our producer. Looking at the perspective of from the private side, you see a lot of different organizations, different customers. Are they looking at things more holistically? Are they looking at things maybe more widget? Do you make it relatable, like back to your storytelling, make it relatable to each position in that organization? Does that help move along the technology?
Absolutely.
That was the question.
I think it does. And sorry about that. Yeah, so I think very much that's what builds the collaboration, with teams. So absolutely, it really is kind of what I was saying. It's how you build trust by making it relatable. And one thing actually that just kind of I'd meant to say earlier, I'm very wary about very broad statements. Okay, and of course I'm making a broad statement, so this is going to be one of those weird paradoxes. But anyway, when companies generalize, so if I come in, let's say I'm one of like 10 SCADA vendors, or Ian's one of 10 security specialist companies coming in, and quite often what you find is people will make broad statements about the stuff that they can't do. So they'll make it seem like as if this is an industry norm, and then say, oh yeah, well, generally it doesn't do this stuff, right? So they'll push some technology, they'll kind of dumb it down to what they can do. And I'm very wary about those kind of statements. So I tend to kind of listen, kind of like a car dealer who says, something kind of fishy about, generally cars will go over 70 miles an hour. You'd be kind of going, that's a strange statement. So I'm just saying, if you start relating it on that basis, you'd be amazed at how many times you'd actually start picking up on the fact that someone is actually steering you away from the technology that is available, but they don't have it. So that's part of what I often bring to just general life.
That's true. No, it's all about collaboration and trust. That's for sure.
Yep.
But I know we could talk forever about this. This is so much fun on the roundtable each month, but we do need to move on to the next segments. And Lee's going to have a great segment coming up. I've got a tips and trick next. So I think I'm handing it back to Chris and Natasha, or maybe I'm going to Lee. So Pete, take it away.
Great. Thanks again.
Thanks, Pam, and thanks to the whole team. So as wastewater treatment utilities continue to struggle with trying to keep up with increased demand, the usual approach usually focuses on building more and bigger wastewater treatment plants. But coming up next, coming up right now, here he is. It's Lee Kibler from our automation panel, and he's going to talk about an award-winning process that they've implemented that actually can vastly increase the capacity for wastewater treatment without the need to increase physical architecture. Hi again, Lee. How you doing?
Hi, Chris.
This moment, we're just having a moment of quiet reflection. Hi, Lee. How are you?
Hey, good, man. How are you? We are looking forward to talking about all things Narita and wastewater.
Right. So before we go into talk about the Narita process, just to give people who aren't necessarily familiar with the water wastewater world a bit of context, would you explain how traditionally a utility would approach wastewater treatment?
Okay. Well, I've got a little bit of business to do to show everyone what our beginning product is. This is what we take in called wastewater. Now, I will not be drinking this water, okay?
That was my first question.
That's our input, and this is our output. So it looks like Dasani, right? And during this process, we use sludge, which we're going to talk about, and this in particular is a granular sludge. So in the background, I'm going to let this settle, and you'll see how rapidly this settles. And this is granular activated sludge, and it is a biomass that's suspended in water. So that kind of helps you understand. So what we're going to be talking about now is enhanced biological nutrient removal activated sludge process. This is more of a conventional process where we take products from our customers, which is fecal matter, ammonia. We take in Happy Meal toys. We take in flushable wipes. We take in grease, pharmaceuticals, dyes from people that are cutting hair, hospitals, industrial. All of this is all amalgamated into a solution that we call wastewater, and then is conveyed to our wastewater treatment facilities using pumps and gravity. All of this requires a tremendous amount of energy. Right. Once we get it to the wastewater treatment, I'm sorry, go ahead.
Oh, I was just going to say, so obviously we're going to be talking about a more advanced process. What's the problem with this process that's solving?
Okay, this process, which requires lots of pumps and mixers and large expanses of concrete. With an enhanced biological treatment plant, we would have anaerobic zone, we would have anoxic zones, we would have aerobic zones, post-anoxic zones, post-aerobic zones, clarifiers. All of these are different structures. And if you look at the diagram on the screen now, you see all these arrows. And anywhere there's an arrow, there is a pump. And keep in mind that you have to keep these flocculated bacterial colonies, you have to keep them suspended in the water to do the treatment. So that requires energy. The energy can be used as mixers, pumps, or aeration. In an anaerobic zone, you would have phosphorus release. And anoxic, you would do a nitrite conversion to reduce nitrogen. And in anaerobic zone, you would do ammonification, which does nitrate. Sorry. So what is ammonia? That's beer. So that's beer and Coke or whatever people drink. So that's one of the primary drivers. Yeah. And in an aerobic zone, we also do phosphorus uptake. And once we clear these processes, we'll go to a clarifier, which is a large concrete structure, which is quiescent. quiescent means still, like a pond,
Right.
and that allows the bacterial colonies to settle out and the clear water to exit to secondary processes where we would either filter or we would treat with ultraviolet radiation. Okay, if you look at the RAS there, that is a return sludge. So we would take the settled sludge and return it to the front of the plant, and the WAS would be the waste stream. A waste stream of this is waste activated sludge, which also requires quite a bit of energy because the water that we deal with is 99.9% water and a very small percentage of, it's like 3.5 grams per liter in this process of actual solids in the water. And these solids have a high affinity to water, so it takes a lot of money to get the water out of this biomass.
Right. So, so what other problems were you trying to solve specifically with this project?
This project, we were trying to solve number one, our capacity issue. Number two, we were trying to solve our future biological nutrient limits, which we're going to be getting tighter over time. The other thing we were trying to solve was, hey, we have a lot of rain here, which tends to wash out this this conventional sludge. It's a very slow settling sludge, and it requires maybe in a conventional plant 2 hours to settle. And if you look in the background here, the Nareda sludge has already settled out. So so this speed of settling high volume of sludge creates an environment where we can have very small tanks, so it's very conservative as far as land. It also, the size of the grain creates a cross-sectional area that emulates a more conventional plant. So in a conventional plant, we would have an anaerobic zone, and in this granular model, the center of the grain would emulate the anaerobic reactor in a conventional plant. The being out from the center of the grain, you would have an anoxic zone, which would be the bacteria that like to live in that environmental structure will be living in that area, which promotes that promotes denitrification, and aerobic bacteria like to live out where there's more aerates. So we can do all this processing in one tank. It's a sequencing batch reactor. So as we need more capacity, we would just add additional units of capacity, more sequencing batch reactors. So all these processes occur in one tank, and the grains take the place of the individual large concrete structures in a conventional plant.
Right. So obviously that's a huge advantage to be able to do it all in one tank. You literally have to build fewer tanks and work with smaller tanks. Right. But let's sort of take a step backwards right now. Tell us exactly what is, as much as you can, tell us what is the Nareda process itself?
Okay, well, the Nareda process is a sequencing batch reactor that uses a ratio of, it's about 8 grams per liter of biomass in the reactor, which is, conventional process, you would have 3.5, 2.5, somewhere in that range. So there is a predominance of granular sludge in there. There is some conventional flocculent sludge in. And the difference being is we're trying to select for the sludge that settles the quickest and keeps the enhanced biological nutrient removal engine, which is the granular sludge, in the reactors. So with a conventional process, we are wasting off the bottom of the clarifier, and we're getting rid of the fastest settling sludge. So it was counterintuitive. Also, the granular sludge grows a EPS layer on the outside of the grain, which creates a very robust biological engine, which like typical toxic shock. If somebody dumps some meth lab or somebody dumps toxic waste in our plant, with conventional sludge, it would be the biomass because it is not very dense. And with the aerated granular sludge, it provides us a lot more resistance to, say, salts and stuff like that up north, and to huge ammonia loads. It may damage the nitrifiers on the outside of the grain, but they grow back really quickly because you have a surface for them to grow.
Right.
So with a sequencing batch reactor, I'm sorry.
It's okay. There's a bit of a delay on the line, of course, because it's going out live. But sorry, carry on.
Yes, the sequencing batch reactor but basically you would bring wastewater in after you've settled out the reactor, and the displacement would push the clean treated water out of the reactor downstream to sequence, to filtration and or ultraviolet or chlorination. So we always taking water into one reactor, and we're waiting or settling in another reactor or aerating in another. So there's always a particular phase going on in different reactors in our plant.
So obviously this produces a savings in terms of having to build physical structures. What are some other cost savings that this results in?
Oh, well, that is true. The structure of the grain reduce. I mean, if you don't need the additional tanks, of course, you're saving concrete, and you do not need additional mixers and pumps to present the sludge to the environmental condition, because the environmental condition exists within the grain. So this can lead to a 50% reduction in energy cost. And we have actually seen that in our installation. Also, the enhanced biological nutrient removal feature allows us to treat our wastewater without using chemicals to remove these environmental constraints. Because if we discharge a large amount of nitrogen and phosphorus to the environment, that creates algal growth in the creeks or nuisance growth of plants, which can destroy the DO in the water. And our fish love DO. So we have a very low total cycle cost because of our reduction in pumping energy and or concrete and or no chemicals required.
Right. So this is a fairly new process. You've already, it seems like you've got it up and running. You've won an award. Congratulations. What is the next innovation in this process that you've started?
Well, our next innovation would be looking on in the future what's going on in Europe. They're taking this Nareda sludge and converting it into a lignite. They're using the lignite that's growing. We talked about the lignite, which is on the outside of the grain. They're using it as a process called chimera, which is they're using a chemical process to remove the lignite, which they're using they're using seaweed, kelp is where a lignite comes from now. In Europe, they're using this chimera process to take 25 to 30% of the huge waste stream called waste activated sludge and converting it to a beneficial concrete amendment. It's also used for biostimulation of plant roots. It can also be used as a repellent for water, maybe helping in the future with some of the things that we're using for PFAS. So this is a wonderful process, and we're looking forward to seeing where it goes in the future in the circular economy of water and wastewater, where we're trying to start recovering assets from the wastewater, such as phosphorus and this chimera and or anaerobic digestion. Trying to turn wastewater into a net zero energy.
So if people want to learn more about this exciting process, how do they do that?
Yeah, all you have to do is look on the Automation Village forum. After I do this presentation, I'm going to put some links up. And if you have any questions, or if I can't answer, I'll certainly put you in touch with somebody. So I'll be keeping track of the forum.
That's great. Thanks, Lee. That was really interesting. I knew nothing about this just merely 3 days ago. Thanks for sticking around. We're now actually going to do the secret code phrase challenge. So while you're here, why don't you, Lee, tell us what the code phrase is?
The code phrase is narrate.
Rita, there it is up on the screen. Open up your email, put this word into the subject line, put natasha.lutz@trihedral.com in the to line, hit send, and 3 people are eligible to win. 3 people might win 3 different $100 gift cards for an online shopping platform. Thanks so much, Lee. Thanks for being on for most of this show. Hopefully, we'll look forward to seeing you again next week.
Thanks, Chris. Have a great week, guys.
Thank you.
Good morning, everybody. This is Pam Moss, Application Development Manager for Data Management Solutions with Hawk. Welcome to the Automation Village Tips and Tricks session. What we're going to look at today on Tips and Tricks is looking at how do you QA/QC your process data. Let's take a look.
So as everyone here knows, there's lots of sources of data. We have our central lab data, which is usually the certified methods, our operators process control data, our commercial lab data, industrial data, SCADA data, and lots of field data. One thing we really talk here at Hawk about a lot is everyone really knows within that organization, they need to understand where that data comes from and how it's produced. You're making a lot of decisions based upon that data. So let's make sure it's good quality data. Understand the sample locations, the techniques, the methods, the sample lines, analytical methods. Everyone should understand that flow of data and understand where it comes from. So coming from the lab world, I always talk about good data management practices, whether it be a process probe or an analytical probe within a laboratory. Data collection must be comprehensive, complete, and reliable. The World Health Organization has an adage called ALCOA. Decisions rely on data being accurate, legible, contemporaneous, original, and attributable. So very important to have good data management in any of these. You're making some very important decisions. So the trick of today is how to QA/QC your process data coming through your SCADA system. So we're going to look at a couple data sources. One, look at that process instrument or analyzer out in the plant that's coming through your SCADA. Take some routine grab samples on your operator rounds and looking at that process instrument, that same location. It may be a field test, or you may bring it back into the operator's lab. That sample coming back, maybe you also split it with the central or certified lab. If you're looking at composite samples for the 24-hour period, maybe you also split between the operator and the certified lab. So lots of ways you can look at data to graph and trend to understand if you're getting some tight control. Now I'm probably preaching to the choir here, but yes, you got to have calibration and maintenance logs. If you don't calibrate it, if you don't record it, you might as well just not do it. So QA/QC, this is really important to understand for process instruments, operator handhelds, lab instruments, operator training. Make sure all that's documented so that maintenance logs are very, very tight and organized so you know that you can rely on that data. Once you get all that data in one place, we use this with Hawk Windows, you can use it with Power BI, you can use it with a lot of systems. Work with your SCADA system and other systems on your alarming policies. What do you want to send notifications, alerts, or triggers on when a event happens? Make it pictorial, get it visual, make a graph, use key performance indicators. What we want to go for is statistical process control and predictive analytics is where we want to go. Right, so here in Hawk WIM's world, what we have our folks do is let's set up some variables, one for an influent ammonia by process probe, ammonia again by operator lab, and an ammonia again by a central lab. 3 places to put 3 different discrete sets of data. Another example would be a raw water nitrate by process probe, by operator lab, and by certified lab. 3 discrete areas that those individual data points go from the sources, then you can really graph and trend. So an example will be an enhanced biological nutrient removal plant here in North Carolina. really, really, really tight limits. In this case, they use an influent ammonia probe through their SCADA. So the blue is what's coming through the daily averages from SCADA. The red is the daily average of the operator grab samples they take back to the lab and run on a DR3900 with TNT chemistries. Then they send a sample that's in green to the certified lab at another part of town. So he wants to track and trend, make sure they're really tight. And when he gets something happening, in this case, the operator did not run the test right, so a great opportunity for operator training. He wants them to track and trend together because he's making some really important decisions going back to SCADA with all this data on enhanced biological nutrient removal. So all data, you can get it in one place, get it on one graph, really understand that QA/QC. Second example is a large drinking water well with nitrate problems. Again, the blue is a nitrate probe in this particular well. The red is a grab sample by the operator running nitrate on a DR900 colorimeter. The green is the central lab running nitrate on an ion selective electrode. He's tracking and trending. Look what happened on this day. If they weren't looking at the operator grab or the lab sample, you would never know there was a problem with this SCADA data point. So they had a problem with the nitrate probe at that well they had to go fix. Another day, they got another alarm because, again, the operator of this particular one needed some more training on how to run the test. So putting all that in one place with SCADA data, operator data, and lab data really helps you tighten up that QA/QC on that data so you can believe the data coming in through SCADA. Helix Water in California has 4 chlorine analyzers. They run handheld tests against it. They want to be a 0.2 above or below that 0 line. If they have some that are going outside that line here, like this midpoint analyzer, they go investigate and see what's happening with that analyzer because they want to be really tight on that chlorine control. And lastly, you can really go off and really do some deep statistical process control. This particular plant in South Carolina has 21 chlorine probes. They do drift. So they're doing daily tests on those, checking those on their rounds for a handheld chlorine versus this. If they're a 0.1 difference above or below, they're going to go investigate and find out what's going on. So in summary, the trick, let's do for QA/QC of our process instruments by taking advantage of the operator field and lab test as well as a certified test. And we can further tighten up our processes and have better faith within that data coming in from SCADA to optimize our processes. So thank you very much.
There's 2 of you.
No, I'm here. So I do have a question, but first I want to say, Craig, very funny joke. Thank you for sending that in the chat. If you didn't yet see it, go over in the chat. Also put your own funny automation joke in there.
There's time.
There is time. So I have one question for this Questions with Nat segment, and that is, what does VTScada have to do with the Automation Village?
That is a good question, and one that I don't think we've been doing it a year and a half, and we've never really touched on this very much. But if you imagine the Automation Village being a live TV show, because it is, then imagine that VTScada is our #1 sponsor, is our major sponsor. So we have other major sponsors for the Automation Village, such as Hawk, such as Riviera Utilities, such as Dispel. Just think of it as being major sponsors. That's why you see our logos. You'll often see our software come up in demonstrations and things like that.
Perfect. So if you have questions for us, you can send them to me any way you want: emails, social media, in the chat, in the comments, on the forum, anywhere you want to put those questions, go ahead. And I'll be back again next month, and I'm going to ask them live.
And now we've got a new segment that we call New News. Hey, Keith.
Hi, Keith.
Hi, Chris. Hi, Natasha. So we start the new news this week on a somber note, I'm afraid. Sir Clive Sinclair passed away on the 16th of September. He was aged 81. Now, for those of you who don't know who Sir Clive is, he was a British inspirational entrepreneur, an inventor who had a series of successful and sometimes not so successful inventions. He pioneered pioneered early electronics, a calculator, a digital wristwatch, which wasn't visible in bright daylight and had a very short battery life on it. But his most successful inventions, I think, were the Sinclair ZX computers range, the ZX80, ZX81, and the ZX Spectrum, which is the computer that I had. It spawned a whole industry of bedroom coders who learned to program basic and assembly language on these devices. I was 10 when I was programming Z80 assembly, so it was very sad to see that he had passed away just last week.
I was actually able to also do some pretty amazing things with my Sinclair. I could actually make my name appear all over the screen. Just Chris, filling the whole screen.
Fantastic, fantastic. So other news, a really interesting piece on Automation World by David Greenfield, who discusses the use of drones as a data source for your SCADA system. And I don't think this is a particularly new idea, but we actually have a white paper on engineering students from the University of Calgary using VTScada Lite to detect abnormal objects in a remote SCADA site. But what David discusses is the use of the onboard camera and sensors to feed back into the SCADA system. Now, we've seen technology like this before, certainly in the offshore oil and gas industry, where the fire and gas systems are using cameras for visual detection of gas leaks and for any flames or fire for the system. And you can imagine a similar situation with the sensors on the drone. There's a lot of computing power on these drones, could be feeding back. We have one system integrator who uses radiation detection systems. Now, these are on Jeeps that are driven around by humans, but now in an event, you can imagine a drone perhaps being deployed to try and bring that data back into the system.
Now, most people will not believe this, but this was not primed. Keith had no idea about this, but Chris just finished an article late last night for Control Engineering Magazine for next month about a VTScada SI using.
Your mind is now blown.
I know,
Whoa.
Tell me about it. So I'm going to put a link to that over on the forum later because it's a very interesting article, Chris, for writing that.
Thank you for saying so.
Perfect. And again, Keith had no idea. He did not even set this up.
Not a setup at all, no. Just a last piece, there was another interesting article, a blog post actually, by Kate Brandt, who's the Chief Sustainability Officer of Google. And Google have come out and announced that they're going to replenish 20% more water than it uses by the year 2030. Now, that's quite an undertaking because according to the blog post, Google uses the water to cool all their data centers that hold all the servers, the production servers for Gmail, YouTube, Google Maps, and all the search capabilities. And with COP26 just around the corner, both literally and figuratively, for me anyway, COP26 takes place in Glasgow in Scotland. It's really nice to see a commitment by a major corporation like Google to the climate action and to the water stewardship.
Right, and it would be nice to see some other sort of big tech technologies out there that also are having a significant environmental impact because of the power requirements. It'd be nice to see some of those giving something back too. I'm looking at you, Bitcoin.
Yeah, some free samples of Bitcoin certainly wouldn't go amiss, that's for sure. There was one quick article that I should touch on just when you mentioned Bitcoin, that the waste from one Bitcoin transaction is like throwing, or is the equivalent of throwing 2 iPhones into the trash. Now, I don't have time to run over that with you, but if you'd like to see links to that news article, or indeed any of the news articles that we've discussed here in the Automation Village, or indeed any of the other items in Automation Village, head over to the Automation Village forum, easy for me to say, and you'll see all the links there. You can see the link on the screen, and we'll have the link in the chat and down below the video as well.
All right, and that brings us to a part of the show that we like to call the end of the show, and where we like to make some remarks. So before we go out, Natasha, what have you got to say?
So I did find a teeny tiny stack of our Automation Village bus stickers. It was a limited edition run of these stickers. So as Keith mentioned, head on over to the Automation Village forum after this broadcast. Find me under Meet the Team section, post a comment there, and I'll send you one of these limited edition stickers. As I said, is a teeny tiny stack about this big.
You could sell it on eBay.
Maybe.
Producer Pete, who's also, by the way, while he was talking during that panel discussion, he was also actively producing this show. Pete, what have you got to say for yourself?
Sorry. This is all live, but we had some internet connection issues, so my apologies. Anyway, but I'd just like to say, remember to subscribe, both on our forum, as Keith just mentioned, and also on our YouTube channel. The more you guys do, the more we can help you. We can get you better content. So please do that.
And newscaster Keith, who, by the way, is all the way over in Aberdeen, Scotland, what to say before we leave?
I'd just say, if you're not already a VTScada user, or maybe you are a VTScada user and you have a home automation project or something fun you'd like to monitor or control, why don't you head over to our website, download VTScada Lite. It's free for use. It has a limit of 50 I/O, but otherwise fully functional SCADA system there. You get all the features of VTScada in a nice bundle. Go website, click download, and grab it yourself.
Thanks, Keith. Now, everyone at home, I hope you'll do me a simple favor. Open up your calendars right now. Go to October 28th and enter the Automation Village, because that's when our next show will be. And we'd appreciate it if you joined us, and we'd appreciate it if you invited someone else to join us as well. So once again, we'd like to thank some people. We would like to thank Lee Kibler from Riviera Utilities,
Pam Moss from Hawk,
Ian Schmertzler from Dispel,
Eric Brown from McKim-McCreed,
and everyone here at the Automation Village team. So